If you write web scraping or testing scripts, you already know the problem. You build a flawless routine using Playwright or Puppeteer, deploy it, and modern anti-bot systems stop your scripts dead in their tracks. We are going to solve that today using CloakBrowser. By the end of the next 5 minutes, you will build out a fully stealth-patched persistent scraping script from scratch. CloakBrowser operates as a system with 2 separate layers. The foundation is a heavily patched custom Chromium binary that handles the actual stealth evasion. Sitting on top is an open-source wrapper designed for Python, JavaScript, or .NET. To follow along, go ahead and open a fresh terminal window alongside your preferred code editor. Because the wrapper layer accepts standard Playwright commands, you can swap out the underlying browser engine without rewriting your entire codebase. That preserves your existing development work while upgrading your evasion capabilities. Step 1 is getting the package. In your terminal, run pip install CloakBrowser. If you are working in Node.js instead, you can accomplish the exact same thing by installing it via npm alongside the playwright-core package. Create a Python script and import the launch function. Next, write navigation commands. Set up the browser, open a page, and go to an example website. Use headless false to see it open. Finally, print the title and close the session. This code is virtually identical to standard Playwright syntax. The complexity of source-level fingerprint patching is entirely abstracted away from the code you actually have to write and maintain. Now, let's execute the script you just wrote by running it in your terminal. You will immediately notice a long pause. Do not terminate the script. During this very first execution, the wrapper is automatically downloading a roughly 200 megabyte stealth Chromium binary. Once downloaded, the system verifies its cryptographic signature to ensure the binary hasn't been tampered with. When that background process finishes, your custom browser physically opens, navigates straight to the target URL, and prints the title in your console exactly as instructed. Relying on this auto-download model eliminates the need for you to manually configure system paths, and it guarantees that your code is perfectly paired with the correct patched browser version. Right now, we have a working stealth browser, but anti-bot systems heavily scrutinize completely blank slate sessions. Returning user profiles are critical for long-term evasion. Let's upgrade our script. Instead of the basic launch command, modify your code to import and use launch persistent context, pointing it to a local directory called myprofile. We will also add a new argument, humanize equals true. This specific modification saves cookies and local storage directly to your machine. This explicitly prevents target websites from flagging your script as a suspicious incognito mode user. Adding the humanize argument takes it a step further by allowing the wrapper to dynamically shape your script's interaction patterns to mimic natural human timing. When running this updated script, look at your File Explorer. You will see a newly generated directory storing the exact identity of this specific session. By combining a persistent, data-rich identity with humanized interactions, you actively reduce the frequency of CAPTCHAs during long-term scraping operations. Once developers get this working locally, the next logical step is scaling it using Docker or CloakBrowser's remote server tool, cloakserve. If you choose to scale remotely, you need to understand a severe security risk regarding the Chrome DevTools protocol port. Port 9222 must never be exposed to the public internet without strict secondary authentication layers. The project actually has a documented history of WebSocket origin validation issues, meaning an exposed local server could allow unauthorized access or even local file disclosure. Remote server management unlocks massive scaling potential for your operations, but it shifts the burden of network security entirely back onto you. Look at what you've accomplished. You have successfully installed the wrapper, verified the stealth binary, and executed a humanized persistent browsing session. Because we didn't provide a license key during the setup, the wrapper automatically utilized the free tier, pulling a slightly older but stable binary directly from GitHub releases. This chart shows how those versions perform over time. As anti-bot detection methods evolve, that older free binary will gradually become less effective at masking your automation. To combat this, you can check the official documentation to explore advanced script configurations, like managing proxy routing or overriding specific WebRTC seeds. Stealth automation is an ongoing arms race. Tools like CloakBrowser are designed to buy you time and maintain API compatibility, rather than serve as a permanent, unbreakable shield.